The one thing that should be on this board that's not here yet is a deep sea generator controller. So you can imagine that also being a remote device. And what are we going to go through? We've got geyser wires with the internal control board taken out and replaced with a South African product called Geyser Walla, Cape Town guy. So now we can IoT this GSC01. Then we've got a son-off. For those people who were next door, the son-off has been tasmatized. So it's running Tasmota, so we can talk to it without having to go into the Chinese cloud. And then the Shelly, I didn't have to do anything to it because Shelly works out the box, which is very nice. And the Shelly is switching these little green LEDs, I think. And then we've got two of the remote LoRa devices. One is running this fan, and I think one's running the strip light. Okay. And then inside here, we've got a very expensive thing from Hager called an MZ915, which can motorize a breaker. So it's sitting on this earth leakage. And so we'll see about tripping it, and we'll see about putting it back up again. And inside this box is a four-way relay, Wi-Fi relay, Ding Tian Wi-Fi relay, and the outputs on that Wi-Fi relay are wired into the MZ915. Okay, so we're going to use Node-RED to control this motorized breaker as well. This is a 12-volt power supply from that breaker over there. Okay, and if the electricians in the room open this box, they won't be happy. All right. There's also this temperature probe that belongs as part of the GeyserWise kit, which we'll hopefully be able to play with as well. All right, so what you're seeing on the screen is that a chrono over there. Okay, so if we go into devices, we've moved things around a bit. And this fuel tank that was set up before is showing open circuits. Okay. And this one here that was set up before is showing open circuits, so we've connected them in the wrong place. But this one here is showing 100%. Right. Where? No, it's showing here. Can you move the thing? Yeah. Okay. See, it's changing there. 70. Okay, you can leave it like that. All right. So that's working. So where is that all done? Inside integrations. Inside tank and temperature sensors, you've got these tank inputs, which are the analog tank inputs on your GX device. And if you have a GX Tank 140 installed, then you see those options as well. Okay, so which tank input is it connected to? One on the back there. Okay, so we're going to turn on tank 2, turn on tank 1. Go back here, and tank 1, there we go. Okay, so setup, European 0 to 180 ohms. Or if you've got an American sensor, it uses, it's completely back to front. It goes from 240 down to 30. Let's say that this is a freshwater tank. And it's liters, and we want a 3-second averaging time because we want things to be nice and fast. The current sensor value is 60 ohms. So if you move the sensor on the shaft, the ohm reading, the resistance reading changes, and that corresponds with a tank reading. Okay. So currently at 0%, let's put it halfway on the shaft and you can sit down. To rename that, this is a KUS S5 sensor. Okay, but typically you would give it a name like Warwick's water tank or something. Okay, and then that is a resistance-based sender. So as we've hopefully all seen now, the resistance on the two wires that come out of this sensor change based on the position of the float, right? This is very safe for fuel because there's no voltage, there's no current flowing, okay? You can't get it reverse polarity because there's no electrical circuit. So a pure resistance reading, if you've got one of these things or something similar to it, you have a current-based sender or sensor, or you have a voltage-based. Voltage-based are 0 to 5 volts or 0 to 10 volts. And this is almost always 4 to 20 milliamps current, right? For current or voltage-based sensors, you must use a GX Tank 140. A GX Tank 140 gives you the ability to connect current or voltage-based senders, not additional resistive inputs. Okay? You get 4 resistive inputs on a Turbo GX, and I think 3 on or 2 even on an Acrano. 3 on an Acrano. And you can't get any more resistive inputs. You can't extend the resistive inputs on a GX device without adding another GX device. Okay, and that becomes quite complicated. Once you know, it's fine, but it's not simple. So you can run multiple GX devices in parallel, and the I/O, the inputs and the relays, all become available to the master GX device. Okay, so they do this on boats sometimes, where they want resistive inputs.
The fuel tanks and the current, just mention that you can't use the current, the volt.
No, we did that. Okay, so now we know that. These you can buy from me. I bring them in from the US. And these you can buy from me, but I just mark them up from Hagar Distribution. Hagar Distribution are the guys who do the deep sea controllers in South Africa. So if you've dealt with Hagar before, you can buy these S5 probes. You go on their website and you click on price lists. You look at the fuel price list. On the fuel price list, you'll find these S5s, and they go to about 2.2 meters, I think. I've got one in my JoJo. Works nicely. Okay, then the other two things on this board are Ruvi for environmental sensing. So this one is the 4-in-1. It can do, or the 3-in-1, I don't remember.
3-in-1.
It can do, no, but this one can do motion. Anyway, we'll have a look at it on all the things that it can do on Node-RED. And then this is one of my LoRa relays. Because this one is sitting close to the GX device, we know that it's the transmitter. So this one is configured to speak to those two. And the only link between this and those two is low frequency radio. It's not Wi-Fi. This does not speak to those devices there by Wi-Fi. It just speaks to them using 433 megahertz low frequency Wi-Fi, which means it's very, very RF, not Wi-Fi. It's very good at getting through walls, through steel buildings and that kind of thing. And with these tiny, tiny little antennas in here, these devices can very easily do hundreds of meters through buildings and all sorts of things. with additional. Pardon? No, it just sits inside. With additional external antennas, which we can supply, like an Omni that sits like this on a wall, or a little puck antenna that sits like this just outside. With the right line of sight and that kind of thing, you can do kilometers. The world record for LoRa is 108 kilometers. Okay. I haven't tested so far. The one other little sensor that I find quite useful. Who knows what this is? Float switch. Okay, open. This thing is lighter than water. Closed. Open circuit, closed circuit. All right. So this can go into a digital input on a GX device. Well, technically this one can't, because the little wires are too small and we don't have any ferrules here. But if you wanted to, you could put this into a digital input, and you can extend it as far as you want on a Ethernet cable or whatever, because at the end of the day, it's just either open or closed. There's nothing flowing. There's no current flowing. So you could say tank pump on, pump off. I don't know. Pump off, pump on.
Yeah.
That's what I said. Okay. And these are like 12 Rand or something. So
Electronic ball.
those are very useful. Yes. Yeah. Okay. So on this side, I've explained everything that we have. Let's have a look at Node Red. Everyone in this room after the last session knows how to get Node Red active on a GX device.
Actually, on your LoRa switcher, is there a possibility later on to do analog inputs, man? Like to have, for example, a tank level in a field?
So on the remote side, is what you're asking, is can I take something like this?
Actually, the analog one.
Analog. Okay, just hold on. If this was connected to the input terminals, you know what the input terminal is here. It's the dry contact input. I can now read that. Okay, the open closed. The new version of this board, I've only made 5 of them, but they're all still working, has an I2C interface and a one-wire interface. So you can put DS18B20 temperature sensors on, they work. I've tested that tank sender, the current-based tank sender with the little voltage conversion board. It works. And I have tested an OLED display, and it works. Okay, so in theory, any I2C device, any I2C sensor, smoke sensor, particle sensor, a proximity radar, whatever, in theory, we could implement any of them. It's just a matter of writing firmware. Okay, and so now that we've got rudimentary support for remote devices, I have to figure out how to send that information back to the gateway. And do I send it every minute as part of the heartbeat response, or do I have triggers on this side that automatically make, like if it's a smoke sensor, maybe you don't want to wait for a minute to learn about that. So we're still going to make some decisions about that, but progress is being made. Okay, so at the point we were at is, are we all totally comfortable getting Node Red up and running? All right. So let's use this nifty little feature of being able to go here and click on this button. Okay. We have to accept this warning because SSL over localhost will always give a warning by definition. Okay, and now we are not browsing Node-RED through the internet. We're not going to VRM and back. Straight over that Wi-Fi router into the GX device. So it's really nice and nippy. The team that we're working with me here earlier, we had some quite long delays when we opened some of these dialogues, and it took a while to populate the information. If you're working local, it's always very snappy. Okay, so let's confirm what's what. So that top one is the strip light. Okay, the bottom one is the fan. All right, it turned on and then immediately turned off. There's a reason for that. The Sonoff TAS motor is running the blue light, and the Shelly, the little blue Shelly over there, is running the green lights. Okay. The Ruby tag is giving us humidity, pressure, temperature, and motion. 4 in 1. Okay. The 4 in 1 used to only come in a little round white one, but now it does also come in that black module. So those numbers there, yeah, the acceleration and whatever numbers, are they changing at all?
No.
Yeah. Okay. Anti-theft sensor result. Okay. So we've got those in the traffic light intersection backups that we do, and the Node-RED just in theory notifies us if someone's tampering with the system, but very boring. Nobody's ever interfered. Okay, and then we've got this one. This is tripped if you do the thing, right? And it's turned back on. If you do the thing, right? So we'll just understand a little bit in a moment what that is. All right. And then we've got a problem. This Giesewelle is not talking. Let's understand quickly why. So I don't usually in these trainings shy away from troubleshooting because it's inherently a part of what we're doing here. So let's have a quick look at the router. If you don't ever log into your Wi-Fi router, I suggest you start learning about that if you're going to deal with IoT devices. In this case, it's a MikroTik, and I want to have a look at the leases to see which devices have which addresses. Okay, and the one I'm looking for is the Giesewelle. The Giesewelle is on 133.18. And it's configured for, now online. Okay. All right. So,
Voila.
so let's see now. View, sidebar, debug. Delete all the noise. Where's Skulk? How do I get the probe temperature out of the Walla?
Walla's got a
Is it
pallet.
this one? Tank 10.
Yeah, thank you. Yeah.
Okay. So, does everyone know what a pallet is?
Yeah.
Does everyone know that you can install custom pallets? All right, let's deploy that.
Yeah.
All right, I'm hoping to see a number there soon. Or does it not show values?
It looks like it's going to show online.
Okay, so let's try the debug node. Some nodes from some palettes, like VIctron, provide you a little hint in the bottom left. Some, the developer hasn't built that in, right?
I just click on the green thing next to like one debug.
Oh, correct.
Maybe waiting for a change of state.
Well, no, it's 5 seconds. Yeah, it's not.
It could be. Okay, 21 degrees. So if I hold this little thing, 22, did it update?
Yeah. 23.
Cool. All right, so let's do geyser automation first. We have our battery SoC set up here, okay? But when we are developing a flow, it's not always useful to have the battery sitting there providing the value every second, because you want to cater for different values that might occur that might be different from where your battery is right now. So you disable that node and you stick one or more inject nodes there that you can use to inject a value that is what you want to test. Okay, so I want to test battery above 97 and I want to test battery below 97. All right. Above 97, this red light comes on, which means we're cooking with electricity. All right. And so what's happened here is we have a 98 that's getting injected into this switch node. The switch node sends any value above 98 out the first connector and below 96 out the bottom connector. Okay. Now, if I grab a switch node, if I'm building this flow for the first time and I grab a switch node and I plonk it in here, and I want to set it up based on what I just showed you, I'm going to put, what was it, greater than 98, 7.
8.
Oh, did I have greater than or equal to?
Yeah.
Okay. And then I'm going to put in less than 97. 6.
6.
Okay. Is that going to work?
Numbers.
Pardon?
You have to switch it to numbers.
Hey, Robbie.
Yes. Literally.
Okay. That thing stuffs people around like you can't believe. Why is this damn flow not working? It's 96. It's 98. What the hell? You have to understand that Node Red is a drag and drop software development. And one of the important fundamentals in software development is data types. That, AZ, that is a string. A string is computer science language for alphanumeric characters. All right? A number is 0 to 9 or a combination thereof. And an A as a string, if it gets converted to a number, it has a value of like 157. That's what A as a number. So if you are comparing 98 as a string to a number, it's going to have a very different value to what you expect. So we want to set them to number so that we're comparing a number with a number and we don't have any unusual things. So if you're stuck and you're going around in circles and you can't figure out what the problem is, one of the important things to check is, are your data types right? Okay. So let's just delete that. So now we know that if it's above or equal to 98, we're going out the top. And if it's less than or equal to 96, we're going out the bottom. Now you see I've also named the switch node with a name that tells me what it does. So at a glance, without having to open it and check that, I can see it on the name. That's useful until you change the conditions but not the label. Okay, just keep that in mind. And then if the SoC is above 98, I'm doing two things. How do I know I'm doing two things? Because out of that first connector, there are two lines. The one goes into a change node. What does a change node do? It takes 98, which goes in here, and which comes out there, still 98. goes in here and it changes 98 to something else. It's no longer 98. All right. What does it change it to? It changes it to the number 60 every time. If it's 99, 99, 99, 99, 60. All right. If it's 100, 100, 100, 100, 100, 100, 100, 60. This is fundamental to flows. Until you change the data, that's what's going to flow through the nodes. Okay? And then the second one is 98, 98, 98, 98 into this node here, change node, which outputs a string, uppercase, word, set point. So this mode node from Gizawala is going to take an uppercase word set point and is going to do something with that. Okay, and what's it going to do? It's going to switch the Gizawala into set point mode. All right. Then this one down here is going to switch the Gizawala into timer mode. So I like the client to have timer mode when the SOC is below 90, whatever, because then the customer can still configure their own timers on their Gizawala app. And even if there's not enough solar, if they've configured the timer, it will still turn on. The other nice thing about the Gizawala is, and the reason why we use it, is that you've got this red button here, right? So if the client doesn't want to look at an app or has lost their phone or whatever and just wants to heat up the geyser, they can press the red button and it's a manual override. So that's one of the reasons why we like it, because it gives us the ability to do the automation as well as have a push button override. Okay, so let's have a look at that interface. 192.168.133.18. So now we're logging onto the Walla itself. And today, Friday. Yes. All those. I mean, it can only think that today is Thursday, sure. Oh, it's in set point mode. What's wrong with it? Okay, so in timer, if it's off, the person can press the button and turn it on themselves. Okay. And what it will do is it will boost to whatever the configured set point temperature is. And in timer mode, whatever that set point is, obviously when it reaches it, then it will turn. Okay. We're all crystal clear. So
Can you change the set point?
yes. So and if you see the set point's 45, if we go to 98, the set point what's wrong here? This here is. So irritating. The last time we did this, there was also something weird going on where sometimes it took the value and sometimes it didn't. Where's Skull? Have you guys ever had any issues?
I'm looking at this and I'm wondering why, because we're getting the temp value, so it's not a Wi-Fi problem.
Yeah.
But for some reason, the MQTT out node is not connecting.
133. So here we're using the REST config rather than the MQTT one.
Okay.
Let's see if that makes any difference.
Is MQTT enabled on Walla?
Yeah.
Okay.
So how do we check that? Hamburger settings. Scroll down to MQTT 1337. Okay, and we know that that is 192.168.1337 is the GX device.
Okay.
Okay,
Click your
so
inject.
let's go back here. Here. See now if we go to 98. Okay, it's good. Before, nothing at all happening. Okay, so MQTT Explorer. It's not on there.
Just hold on. There's no debug enabled. Just go to the Giza Walla. The 60 should be there.
From the debug.
Just click the 98 again. Yeah. No.
Let's get MQTT Explorer quickly.
Your house debug is hidden.
Yeah, I'll enable that.
So the software is downloading.
Yeah.
Allows you to log into the broker and see the data coming through, or is it being blocked, or is it updating? Sometimes it's just being blocked. It's pretty nifty software. Write it down. It helps you also to identify other topics that you may not think you need it. You might install that Shelly and see, but oh goodness, this thing's got a power function. I want to display the power, or there's a voltage. Maybe I want to display the current. We've even had it where I couldn't find the VIctron palette for something specific. And if you go through the topics, you could say, oh shit, here's ESS status. And you use a normal MQTT out node, copy and paste the topic, and there you get your ESS status in your flow. But there's a palette, there's a node, I know it is. Couldn't find it at that instance. But it's pretty cool software.
Okay, so let's return to Giza Walla and do some troubleshooting there once we've been through some other stuff. Okay, one of the methods of communicating with IoT devices is HTTP. HTTP is the same protocol that you use to browse the web. And so the Tasmota Sonoff over there, we are talking to that one over HTTP as an example. So we've got the same kind of idea here, the same kind of switch decision above and below 95%. You see the SoC node is disabled again because it's not helpful for testing. And here, there's two things that are different. The first one is on all of the other nodes, we've been interacting with something called message.payload. This one is message.url. Why message.url? Well, we can answer that question by looking at the node that we are sending to. We click on that node, and then click on this little down arrow, click on the book. we'll see here the documentation for the node. You'll see that documentation changes based on the node I'm clicking. So the documentation for this node says that the input is URL. Okay? And it will tell us that its output is a payload. So we can process a payload as an output, but we must supply the input on .url. So what is the URL? If you went to the Tasmota documentation, the documentation would tell you that that's the format of the URL required to send a command over the web to turn the switch on, right? And its return, which would be in that payload object, is a little bit of JavaScript object notation, or JSON, which has a parameter or a key called power and a value of on. All right? No guesses of what happens if I change that on to an off. Okay, why the delay? Because it took a while to get to the router and then to get that thing to answer to the router. Okay? And now it returns the key value pair of power off. Yeah. All right. So we are sending that string message.url to this node, which is an HTTP request node. And the HTTP request node has an input and an output. And what we expect to see on the output is that message.payload, right? So above 95%, I want to see the light go on. And if this debug node is enabled, then I will see power.on in a payload object. Okay? If it's below, I'll see the light go off and the response from the web server that's running on the server is power. Super simple, super insecure. No authentication. There's no username and password there. So if you're turning on and off the keys to the nation, well, this is not the right method. Okay. Then we've got that Shelly up there. Now you see this node looks a little bit different. It looks a little bit different because it's part of the palette supplied by Shelly, and because their designer, developer doesn't know how to use an alpha channel on an image to get transparency. But you can see that it's a Shelly supplied palette because all of Shelly's devices are listed here. Okay? You can choose the very specific device that you want to interact with, and it will then change the options that are available to you based on that device. Okay? Now, if you go to the Shelly documentation for that palette, so let's go to Manage Palettes. Shelly, see there's an update available here. Okay? We can see the nodes that palette offers us. Okay? And while we're looking at this documentation, let's just do the update anyway. So it's called Node-RED Contrib. Node-RED Contrib Shelly. Okay, so let's have a look at this documentation. Node-RED Contrib Shelly. There it is. Okay. Now if we scroll down here, we find 1 p.m. Plus 1 p.m. I think. Yeah. Okay, the documentation says this is the string of text that you must use to interact with the Shelly 1 p.m. Awesome. Easy. Copy and paste. You're soon to have problems in your life. Okay, so let's see. So we take inject node, right? Actually, let's take a new one. Right. By default, an inject node just generates a timestamp. What's a timestamp? It's a long number. What is that number? It's the number of seconds that has elapsed since the 1st of January 1970. Why that date? Because geeks are all powerful. Okay. 175-103-061-9266. Okay, that's the number of seconds that have elapsed since the 1st of the 1st, 1970. And you can obviously convert that to a date. All right, you can convert it to a date down to the second. So if that's ever useful to someone, that's what a timestamp is. But we don't want a timestamp. We want to send a payload, some JSON in it. And if you click on these three dots here, you get a nifty little editor. So we can go and do our copy paste. Okay, which is going to turn the switch on. And then after 2 seconds, it's going to turn it off. All right? Cool, cool. Why is this thing for play?
I don't understand what up you said.
It's a momentary switch, like to toggle a gate motor or something. You just want to.
Was it part of the data?
It was. So let's just see what the problem is here. Okay, so it doesn't like the fact that there are open and closing curly brackets because it assumes that those are already supplied. Right? You know, we're happy. No, it's not. It's not. Copy and paste doesn't work so well. It's
Just check on the end.
pardon?
Is there not a calibration on the end?
Yeah, there is, but it belongs to this one, or the parameters. Okay, I don't want to waste too much time on it. The bottom line is that the JSON in the Shelley documentation is wrong. Okay, it's wrong. It needs to be quoted. The key needs to be quoted, and they are not quoted in the documentation. So you sit there stuffing around forever trying to work out what's wrong, and actually Shelley's own documentation is what's wrong. So we can prove this by hopefully really putting my thing on the block here. But if we take this and quote it, right, and then quote this. Okay. We quote this. And we quote this. All right. We're nearly there. Only problem is that there should be a comma here, I think, and there should be quotes over here as well. If I'm correct. Okay. Yeah. And yeah. Open brackets, methods, switch set, parameters, IDE, close. So it's close. Okay, I'm harping on this because these are the little things you have to kind of get on top of to make these things work. Okay, so the problem here is that comment. So the close brackets are considered to be part of the comment. Is it? Okay. Bottom line, copy and paste doesn't always work, even when you do it from the official documentation. All right. So what is the on doing? The on is sending this little piece of JavaScript, which you can get from us. Switch.set is the method. Parameters are ID 0 and on is true. Okay. And where is the
Last string now, I struggled to get this together. I'm looking for the living book now. But funny, I really listen to it.
okay, so after two. So let's just see this one how it works.
And just work with use that.
Sorry guys, I don't use Windows often. Toggle underscore after two.
Seems to be really
Toggle underscore after two.
The developer should do it. It should use my actual drop down.
Done.
Busy power.
Done. So if I send that on, I expect to see them to go on and then after 2 seconds to go off. All right.
There we go.
That's not what I want for an on toggle. I want it to just stay on, which means I need to delete that. Okay, but I'm going to comment it out so I can display I broke it because there's a comma at the end of the sentence above that now needs to be removed. Yep, they are. Okay.
Or is it swimmers? Is it swimmers?
It's probably not liking the computer, is it?
Yeah, that's probably what it boiled down to. Okay, we want this to be true.
Ek moet dit ook speel so net iets help asseblief.
Okay,
Krijg jy
so on now sends the Shelly node the on object, and then off sends it the off object. Okay, you can also use a function just to generate a little payload to do that if you like JavaScript. Let's talk about things for a bit. All right. So what is this relay here? So this one is set up via MQTT. So let's have a look at this MQTT Explorer thing we were speaking about earlier. So we want to connect to the GX. We know the GX is on 192.168.133.7. Okay. We haven't set up any authentication, but you can and you should if the system is powering.
Why didn't you know that?
It's because when we look, because this, remember the bit where I said if you've never logged into your Wi-Fi router, you should, because the Wi-Fi router is configured to always give the Acrono that IP address. Always. Always. The static IP address, and it will. This iPhone and this desktop PC have a D next to them here, which means they dynamic. Their addresses could change. But let's say I wanted my one to never change. I click make static, okay, and then and then it will always get that IP address
So for the dynamic lean for a little time.
period of time, and then it may change. Usually keeps the same one, but it may change.
Follow a router where you go to network settings, Wi-Fi, Ethernet, just make it static fast. Yes, thanks that.
Okay.
It's not as easy as what I'm saying because there's rules, but
It's an important question,
Yes.
right? If you install a Giza Walla, the day you set it up, it all works, it's great. You leave. Something changes on the customer's network, it gives the Walla a different IP address, nothing works again. So this is what I'm saying, the your Wi-Fi router and your ability to issue static IP addresses to each of your devices that your node red flows are referring to via the IP address is an important skill to learn. It's not complicated, and most of the routers have a very easy one-click option to make an IP address static.
What if I can just add a comment there, what I do is I note down the MAC addresses for each device. I make a note, because if the router changes, then you'll lose that configuration, but then you can just go in, because the MAC will never change, and then you can bind it again.
What Stefan's talking about is 5C879 Charlie 4D blah blah. That's the MAC address. It's a 12 character hexadecimal number. So 12 to the power of 12, many possibilities of that number. And every single device in the world that connects to a network has a unique MAC address. Okay? So if you make a record of the MAC addresses of your devices and you know that you've allocated F0B040 Foxtrot Charlie 9721, you know you've allocated that MAC address to 133.7. When lightning strikes your router and you have to replace it, you can rebuild this table by, I know I gave that MAC address that IP address. Okay. Otherwise you have to do it from scratch. Say again? 12 to the 16. 12. It's actually 12 to the 255 because you can have 255. Yeah. Which is a big number. Any questions about that before we move on with it? Okay, so 15 is the IP address we're looking for the Ding Tian. But let's have a look at it in here. Where is it? Yeah. All right, so we see that inside this box is this 4-channel relay I'm talking about. And so we can see that it's got these R4, R3, R2, and R1 values because those are the 4 relays. There's lots of other devices on there. So let's look at it. 192.168.133.15. Admin admin. Also not controlling something important. Okay, so here we can manually fire any of the relays, but actually what's happening to control that Hager is a combination of relays firing. So when you've deciphered the hieroglyphics in their manual, you'll see that what needs to happen to trip it is you want to, now this stuff here comes out of the manual of that Chinese relay. If it doesn't make sense to you, don't worry about it, just understand that this can be done. Okay? It's telling us that we are sending it what it calls jogging to relay 2. We want to set it to on for 2 seconds. All right. So if we set the relay on for 2 seconds, hopefully we can get that damn red light off for a change. because the earth leakage will be tripped. All right. Now, in order to get the relay back on, we have to fire relay 1, and then after we've enabled relay 1, we have to fire relay 4. All right. That's what the Hager MZ915 wants. So what we do in this little function is we send relay 1 out the first connector, we send relay 4 out the second connector, right? First connector, second connector, okay? And then out of the third one, we then want to turn both of those relays off, okay? So the first one says relay 1 on, the second one says relay 4 on, the third one sends a string called delay next, right? Delay next goes to a little delay node, which does nothing for 5 seconds, okay? And after 5 seconds, it then sends off and off to relays 1 and 4, right? The first one, which is firing relay 1, immediately fires relay 1 on. The second one delays for half a second before closing relay 4. So now we've got the correct sequence, relay 1, then relay 4, and then after 5 seconds, both of them will be switched off. All right?
Does
So
that mean 4.5 seconds? From the start, 4.5 seconds.
relay 4 will turn off 4.5. Relay 4 will turn off 4.5 seconds after it turned on. Relay 1 will turn off 5 seconds after it turned on. Okay. So click, up, off, 5 seconds later. Okay, Giza Weller back on. So where do we use this? Remote sites where it genuinely, because they're expensive, those things are like $3.5 grand. Remote sites where it's going to cost you more than that to get in your car and drive there just to break it. Cell phone towers, that kind of thing. And then you make damn sure that your internet connection is powered from the DC bus.
That's not for your kids.
Or just put it on your PS with them.
Something.
Dedicated, yeah.
Okay. The LoRa stuff. So if you could please just grab that temperature sensor with your hand for me and just hold on to it for a bit. We've got temperature sensor reading 19.75 at the moment. And 19.94. We wanted to get above 22, I think. And above 22 goes out the above or equal. That's too much. No, it's already nearly there. So above 23 goes on the first one, and the first one turns unit 38 on, which is the fan. Okay, you can let it go. Thank you. And when it gets below, you see what I did here as I labeled it and then changed the numbers and didn't change my label. Okay, when it gets below 22, it's going to turn off. All right. How is it doing that? It's sending a payload with this very simple JavaScript address and the address 0x38 and a relay value with the number 1. Okay? And it's sending it to a topic. So payload and topic. It's sending it to a topic here. LoRa, Thunder LRS, chip number, to the TX node, which is the one we want. And it's sending it to this endpoint called control. Control will consume an address and a relay state. All right? And what it will do is it then sends a 433 megahertz packet that says, hey, anyone, if you're 0x38, I'd like you to turn your relay on. And any device in the area that is configured to listen on 0x38 and is configured to receive from whatever that one is as security, will then receive that message and act accordingly. What this means is it's very easy to do one-to-many. I think it's the application you guys had. So, in fact, you wanted many-to-one. You wanted many-to-one. So it's very easy to do one-to-many. So, for example, we added a solar system to a property developer's house, really big house, really fancy, complex house. No way in hell we're running secondary supplies to all of the DBs. So we put 8 of these relays on all of the DBs around the property, and when the power fails, we send the gateway sends one message: "Hey, you 0x38, please turn your relay off." And it just so happens that there's 8 devices that identify as 0x38. They all say, "Cool, no problem, turn my relay off," and the non-essential loads drop out. Okay. That application, which I really like, they've got one generator, 2 solar systems, 3 solar systems. So if any one of the 3 solar systems needs the generator, they want any one of the 3 of them to ask the generator to start. So then we have 3 transmitters configured with the same receiver address, and the receiver will listen to a command that's sent by any one of the 3 of them. Okay, meaning to one, works perfectly. In this application that we're looking at here,
I want to take this away. I can't disconnect this or snap it.
no, that's fine. Disconnect it and just plug it back in again. That's my strainer.
Yes. Transport is out.
Okay, so now what I was talking about there is control based purely on these 2 wires here, right? The generator start stop that I'm talking about there, the control of the loads in the house, and the normal one-to-one remote generator start stop where you're just not using MQTT, not using anything clever. It's a piece of hardware and a piece of hardware. Power. You can take the relay output that you would normally start the generator with and wire it into the bottom 2 terminals here, which is the dry contact input. All it does is it listens, is it open or closed? If it's open, I'm going to tell my remote unit or units to open. If it's closed, I'm going to tell them to close. Dead simple. So it's literally just a wireless extension of a relay signal. Relay input, relay output. So this is dry contact in 1 and 2. It's 2 wires to get contact or closed or open, and then normally open, normally closed, and common. That's it. All right. But what if you've got one of these and more than one of those, and you want to say to it, "I want you to switch on, but you to stay off." Okay. So now it's one-to-many, but discretionary. There we've got MQTT. So as long as the GX device can speak over the Wi-Fi to the gateway device, which is always going to be close to the GX, then we can give it specific instructions. And the specific instruction is what's being done in let me just disable this. So this unit is 37, configured with the address of 37, and this unit is configured with the address of 38. Okay, and so we can use MQTT to send the gateway the string of which unit by address and what relay state we want it to have, so that we can control any number of remote units that are not connected to Wi-Fi. But as long as the gateway unit is connected to Wi-Fi, we can send the instruction to others. So let's say it's controlling lights, and you want to only turn those lights on, then you would only send that command. Okay. Then digital inputs. Who has never used a digital input in the room? Okay. Digital input on a GX device is basically just reading an open or closed signal for most of us. It can read pulses and all sorts of other things, but for most of us, the application is an open or closed. Okay? This kind of thing. Door open, door closed. Another application that we've done for people is a normal little light switch toggle mounted on the wall next to a generator that's connected to a multi-plus with a grid. If the client hits the toggle when the generator starts, or instead of the toggle switch, there's a relay built in that closes when the generator starts, that closing is detected by the generator, the digital input, and the node red flow then adjusts the input current limit down to whatever the generator is comfortable with. When the generator stopped and it opens again, then the node red flow sets it back to the normal grid input current. Okay? So AC input type can be changed as long as it's a parameter that can be changed on node red. Yeah.
Is that also the one you'll use if you want to protect your panels against theft? Just wire something through, and if someone breaks that cable, someone is potentially working on your panels.
Yeah.
Is that the one they use on the group?
Yeah. Digital input. If you put a single circuit through your solar panel installation, just one piece of wire from one end of the solar array into your digital input, out of your digital input back to the other end of the solar array. Anyone who steals a panel breaks that circuit, and the digital input will open. Okay. Anti-theft solved. So let's test that for a second. I really would like to troubleshoot, and I'm going to resist the Okay, so let's look at the digital input. I have relay 2 of the GX connected to the dry contact input of that LoRa device. Okay? If it closes, that LoRa device is configured to send the firmware is configured to send a packet to 37 telling it to turn on. Okay? But hold on, what's going on here? Because when I turn that on, something's happening with this blue light as well. What's up with that? Like half a second later, the blue light goes on, and then half a second later, the blue light goes off. What the hell's up with that? What's up with that is the firmware on these LoRa devices. This one says, oh, I detect closure on my input. I'm going to send the packet I've been programmed to this.
Two strong guys, quickly, sorry. Two strong guys.
So I'm sending the packet over here to this one to ask it to close. It closes. Its immediate job in the firmware is to send a packet back to this one to say, I closed my relay. This one is then configured to wait for half a second before closing its relay, its local relay. All right? Now you could have an indicator light there so that you can see on the GX side of the system that that relay has confirmed that it's closed. Or you could wire it into the digital input, which is what I've done here. So, hey, please close. Yes, I've closed. Into the digital input, it closed. Right? So what do we do in the node read flow there? In the flow, when the Venus GX relay is closed, packet comes here, says closed. This one sends the packet back saying I'm closed. It sends it to the digital input, which is there. Digital input. So I made that. The digital input is then configured between 10 and 11. What's 10 and 11? Well, if we open the digital input node, we'll see that 10 is running and 11 is start. Why? Because I configured it as a generator, start, stop, in digital input. Okay? So, why is it running? Because we know in the VIctron world, when the relay is closed, that means I want to start the generator, and when the relay is open, it starts. Then, there's a change node with the same HTTP command we saw earlier into an HTTP node. So, when I set packet on, confirm, lights will click on. So, this blue LED here is confirmation that that digital input is reading this relay is closed. So whatever you want to do with it, you can do with it, but that's the very, we need to slow down time. Because we've got to process all of that in half a second. Okay, so this one is completely broken. I think let's troubleshoot this one until Andre tells us that everyone's gotten bored and we've lost it.
Need Andre to say.
You guys can. You just tell me when to stop.
I want to show you something cool that Peter showed me. Click on one of your debug outlets.
Yeah.
The last check, open it. Now open it. Yeah. The last checkbox, that node state, check that and done and deploy. So instead of sending it to the debug, it's going to send it to the bottom of the debug node.
Okay.
So instead of waiting for 21 to appear on your right-hand side debug palettes, it will appear like the connected or the VIctron node saying the status underneath that.
Okay, well, let's look at that on which one was the temperature sensor?
Yeah.
One did we?
There was one we did with VIctron.
Yeah.
But just make sure we don't send it to. I don't know what's going to happen with 2.
Okay.
You send 2 things to the debug. It's going to come out.
It will comment or it will put in the info.
Okay. Okay.
So enable nodes. Any other questions out of this session? Node status deployed. 20.03.
No.
That's nice. Cool.
And obviously the first tick box would turn the debug on the right off. Don't want it to run on debug. You only want it as a status.
This one?
Yeah, if you do that, it won't show on the debug.
The first one.
Yeah,
Oh,
then it doesn't go to the debug.
this one.
Yeah,
Okay. Cool.
because a lot of the, like you said, it's not built into the nodes, it's just the way so you can see it, but you don't want to clutter everything.
And you have specific things on the debug. Some
Yes.
things on the dash.
Okay, so if we deploy that, okay, cool.
And that brings us to the end of this video. If you've made it this far, I sincerely hope you have enjoyed the content and learned something new. If so, please leave a like and subscribe to support the channel, as well as to get notified of any future videos. Oh, and make sure to check out this video as well. You can also subscribe over here. And this one is pretty cool too. Lastly, don't forget to visit and sign up for a free account at the Blue Power Pro Forum.